This is an audio long read from Nature. In this episode, many people have no mental imagery. What's going on in their brains? Written by Elizabeth Quill and read by me, Benjamin Thompson. Think about your breakfast this morning. Can you imagine the pattern on your coffee mug, the sheen of the jam on your half-eaten toast? Most of us can call up such pictures in our minds. We can visualize the past and summon images of the future. But for an estimated 4% of people, this mental imagery is weak or absent. When researchers ask them to imagine something familiar, they might have a concept of what it is, and words and associations might come to mind, but they describe their mind's eye as dark or even blank. Systems neuroscientist Max Shine at the University of Sydney, Australia, first realised that his mental experience differed in this way in 2013. He and his colleagues were trying to understand how certain types of hallucination come about, and were discussing the vividness of mental imagery. "When I close my eyes, there's absolutely nothing there," Shine recalls telling his colleagues. They immediately asked him what he was talking about. "Whoa, what's going on?" Shine thought. Neither he nor his colleagues had realised how much variation there is in the experiences people have when they close their eyes. This moment of revelation is common to many people who don't form mental images. They report that they might never have thought about this aspect of their inner life if not for a chance conversation, a high school psychology class, or an article they stumbled across. Although scientists have known for more than a century that mental imagery varies between people, the topic received a surge of attention when, a decade ago, an influential paper coined the term aphantasia to describe the experience of people with no mental imagery. Since then, aphantasia has shot into the canon of unusual phenomena that are invaluable for studying how the mind works. Like synesthesia, in which people's senses are connected in exceptional ways, so they hear colours, for example, and prosopagnosia, also known as face blindness. Aphantasia has opened many new research avenues. Much of the early work sought to describe the trait and assess how it affected behaviour. But over the past 5 years, studies have begun to explore what's different about the brains of people with this form of inner life. The findings have led to a flurry of discussions about how mental imagery forms, what it is good for, and what it might reveal about the puzzle of consciousness. Researchers tend to define mental imagery as a conscious experience, and some are now excited to study aphantasia as a way to probe imagery's potentially unconscious forms. Cognitive neuroscientist Julia Kabay at University College London is among the researchers interested in these questions. She was shocked to learn about aphantasia in 2015. Her own intensely vivid mental imagery is at the other extreme of the distribution. She has hyperphantasia. The fact that there are people with a complete lack of mental imagery brings fresh ways to study this internal experience, she says. Quote, "How does it affect our emotion, our perception, our attention, our memory? We can understand this with aphantasia." Neurologist Adam Zeman at the University of Edinburgh and the University of Exeter, UK, began studying aphantasia in 2003. He met a man who, after a minimally invasive heart procedure, complained that although his visual perception remained normal, his mind's eye had vanished. Scans of his brain showed the expected activity when he looked at images of famous faces, but notable differences from control individuals when he tried to imagine the faces. After Zeman's team published a case study in 2010, Zeman heard from more than 20 people who said that they too lacked mental imagery, but they had lacked it their entire lives. Zeman's team surveyed those people, reported the findings, and introduced the term aphantasia, tacking an A to the front of phantasia, Aristotle's term for the mind's eye, in 2015 in the journal Cortex. Zeman says that he was inundated with messages after an article about the paper appeared in the New York Times. Since that article, some 20,000 people have contacted him with their own stories of mental imagery. "I didn't expect it to explode quite as it has," says Zeman. "If you are studying what you regard as a rare neuropsychological phenomenon and you get half a dozen people in touch, that's big time." The 2015 paper and subsequent research has revealed how much aphantasia can vary. For instance, people with aphantasia often, but not always, lack the ability to imagine in sensory modalities besides vision, having no mind's ear, for example. Some people with aphantasia report dreaming in pictures, but others don't. Researchers have also found that aphantasia seems to have a genetic component, with the likelihood of having aphantasia increasing tenfold if you have a sibling who has a weak or absent mind's eye. And aphantasia might be more common in people in scientific and technical professions than in people with careers in the arts. Zeman and others say that aphantasia doesn't seem to make much of a difference to behaviour, and although it might influence creativity, it by no means precludes it. Instead of calling it a disorder or condition, Zeman describes it as an, quote, intriguing variation, end quote, one extreme on a distribution of mental imagery capabilities. Much of the work characterizing mental imagery relies on asking participants to describe their experience. But such methods are subjective, and they can't separate true variations in experience from variations in how people describe or interpret that experience. So, some researchers have been attempting to come up with other techniques. Neuroscientist Joel Pearson at the University of New South Wales in Sydney and his colleagues developed an approach that takes advantage of a perceptual phenomenon called binocular rivalry. When a different visual is presented to each eye simultaneously, for example, a pattern of green lines to the left eye and red lines to the right, a person's perception toggles between the two instead of blending them. Nearly 2 decades ago, Pearson decided to see what happened if he imagined one of the visuals in his mind's eye. In this case, only the green lines or only the red, before the test began. It turned out that whichever pattern he imagined was the one he saw during the test. The researchers developed this finding into a technique to measure the strength of mental imagery. In a person with typical mental imagery, imagining the red pattern results in the person being more likely to see that red pattern during binocular rivalry. But a person with no visual imagery will not show this same bias. Pearson has been studying mental imagery ever since developing this method. There are other techniques too. A person's emotional reaction to scary stories, measured by how much they sweat, can be a good proxy for how vividly they imagine what's happening in the story. And when researchers ask someone to imagine a bright light, the extent to which their pupils constrict correlates with the vividness of their mental imagery. A decade of work left researchers convinced that aphantasia is a real phenomenon. But many are puzzled by how little it seems to affect behaviour. Behavioural tasks that are thought to depend on mental imagery don't seem to be a problem for people with aphantasia. They perform relatively well on standard memory assessments, and they seem to be able to rotate objects in their mind to determine whether an object in one picture matches another presented from a different angle. I play sports. I can draw diagrams of the brain, whatever you want. But for me, when I try to imagine a purple dinosaur juggling on top of a bouncy ball, nothing shows up, says Shine. He says the big mystery is how the brain can function typically in all these ways, but at the same time lack this one specific ability. When scientists started looking for the brain signatures of aphantasia, they expected to see differences in the visual cortex. This is the area that receives and processes visual information during perception, and it's known to be active when a person pictures something in their mind. Most researchers have thought of mental imagery as vision in reverse, with higher level brain areas sending signals to lower visual areas to generate a conscious image. But studies have suggested that when people with aphantasia attempt to imagine something, they activate the visual cortex in ways similar to that seen in control individuals. Perhaps, some researchers say, that brain area is forming visual representations in people with aphantasia, but the conscious mind can't access what is there. During her PhD, Kabai decided to study the relationship between activity in the visual cortex and a person's experience of imagery. She wanted to find out whether what she and others call sensory representations in the visual cortex must always come with the experience of imagery. But she also wondered whether aphantasia was a problem with voluntarily conjuring up images on demand. So she and her colleagues took an approach that didn't require participants to do that. The team scanned the brains of people with and without aphantasia while they listened to sounds that should spontaneously trigger a sensory representation of whatever made the sound. Barking, for example, should trigger representations of a dog in the primary visual cortex. Then the researchers fed the brain activity into a machine learning algorithm to see whether it could predict the sound content. Hearing a dog bark did generate activity that represented a dog in both typical images and people with aphantasia. But despite the existence of that activity, people with aphantasia reported seeing nothing in their mind's eye. The finding suggests that these sensory representations, thought to underlie mental imagery, can remain unconscious and so are not sufficient to trigger imagery on their own. The team also probed voluntary imagery, asking participants to visualize what was making the sound. In this case, the algorithm couldn't decode what was being represented in the visual cortex in people with aphantasia. Kabai calls the findings, quote, puzzling, end quote, and says that aphantasia might be a twofold problem involving not experiencing imagery consciously and not being able to voluntarily generate it. Work from Pearson's group suggests that people with aphantasia do have representations in the primary visual cortex when they try to imagine, but that these differ in subtle ways from those of people who experience typical imagery. In a study published last year, his team scanned the brains of people with aphantasia and typical images, while they looked at stripe patterns on a screen, and when they attempted to imagine those same patterns. The findings pointed to differences in the representations that form in the primary visual cortex of people with aphantasia during perception and attempted imagery. Although the representations are there during attempted imagery, Pearson says, they are somehow weak or changed in some way. Is it functionally different, warped, blurry, in a different part of the brain? He asks. We don't have the answer to that yet. Brain studies also hint that altered connectivity between brain regions might be at the heart of aphantasia. This fits with leading theories of consciousness that focus on connectivity. In aphantasia, it's possible that visual areas and higher-level brain areas are not communicating in a way that allows for the conscious experience of the mind's eye, researchers say. In one study, cognitive neuroscientist Jianghao Lu at the Paris Brain Institute and his colleagues used a high-resolution form of functional magnetic resonance imaging, or fMRI, to observe the brains of people with aphantasia while they attempted to imagine animals, faces, or the appearance of French words, for example. The study found reduced connectivity between an area involved in visual processing called the fusiform imagery node and frontal regions that are active during imagery tasks. From this and other work, Liu proposes that conscious imagery requires the integration and amplification of, quote, subliminal visual representations, end quote, that are present in the visual cortex. There might be various types or patterns of brain activity that result in an absence of mental imagery. This would fit with self-reports suggesting that aphantasia is experienced in various ways and can take different forms. People tend to assume that their inner lives are identical, says Shine, but, quote, the way that the world shows up to people has a massive, massive variation to it, end quote. He thinks that accounting for this variation is central to understanding how human brains work. Although aphantasia doesn't seem to have a big effect on how people get on in life, studies show that it does reduce the richness of autobiographical memories. People with aphantasia recall fewer vivid details from their pasts. There's a thinness to their recollections, says Zeman, so they can't fully relive their memories. Wilma Bainbridge, a cognitive neuroscientist at the University of Chicago, Illinois, says it is hard to disentangle mental imagery from memory. Even creating a mental image of something in the future probably requires you to rely on your memory. Her laboratory has been investigating the content of memories, what they look like in someone's mind, and people with aphantasia provide an interesting test case. In a study reported in 2021, Bainbridge and her colleagues asked people with and without aphantasia to study a scene and then draw it from memory. They wanted to capture what might be lost when people describe their memories in words. Quote, aphantasic individuals drew less, fewer objects, fewer details. They spent less time drawing the objects and used less colour, Bainbridge says. But by some measures, their responses were indistinguishable from those of people with typical imagery. They identified where objects were in space just as well, and they were just as good at recognising the images they had seen when asked about them later on. They used more text in their drawings, suggesting that they were scaffolding their memories with language. This study and others reinforce the idea that there are many components of memory: object, spatial, semantic, a framework that could be important for understanding and treating diseases such as Alzheimer's, in which several forms of memory seem to decline at different rates. Xionan Lee, a master's student in Bainbridge's lab, found out she has weak visual imagery during a high school psychology class in around 2017. I don't have a deficit. To me, it is fine, she says. But it has left her curious about the subject. She is interested in what techniques people with aphantasia might use to compensate. She wonders how, for example, they can recognize faces without picturing them. And she wonders whether it is possible for a person to train their mental imagery ability. At the other extreme, many researchers are now interested in how vivid mental imagery might relate to hallucinations in schizophrenia or Parkinson's disease, or to the visual intrusions present in post-traumatic stress disorder. It has been proposed that aphantasia might be protective in these and other mental health contexts, Zeman says. Shine says that seemingly negative aspects of aphantasia can be viewed as positives. For example, he says he doesn't get as lonely when he travels because he doesn't have an image of family members' faces in his mind's eye. I don't sit there and dwell on it, he says. I'm able to put it out of my mind. To read more of Nature's long-form journalism, head over to nature.com/news.